All right, so we're back to rotation again, but this time we're going to see a slightly different version of it. So in the first video, we saw proper rotations, where it's just a rotation like we're normally used to seeing. Today, we're going to discuss what an improper rotation is, and we'll also see what inversion is. So that's a simple one, so we'll put them together into this video. All right, so previously we talked about doing successive rotations. So for example, if I did a C4 followed by another C4, that's just a C24, which we recognized was a C2. And there's tons of these that we can do. So for example, I could do 3 C4s, so I could get a C34. But what happens when I do C4, 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 C4? So in other words, a C4, 4. Well, we recognize this is just back to our initial configuration. It's identity element. We can do the same thing with a reflection. If I do a reflection followed by another reflection of the same plane, I come back to identity. And we're going to see that inversion has that same characteristic as reflection. If we do it, it undoes itself here. So successive operations is an important part of what we're going to be doing here to understand improper rotations. So that brings us now to the improper rotation, which we're going to give the designation S with a subscript n, where n is going to tell us about how much we're rotating. So an improper rotation is the combination of a rotation with a mirror plane. That's what gives us our improper rotation. So it does feel like this is contained in the other two, but this is a unique element that we'll have to identify from time to time. And here's a good example that I've got above it here, where I'm saying, let's look at this molecule, and let's do first a C4 rotation here. So we're just moving this by 90 degrees to get to this intermediate structure. We can call that B, A, and C over here. And now we can do a reflection across this horizontal plane here to bring us back to this structure. So again, remember the labels here, A, B, C, and D, don't actually matter. They're just the atoms that we have. Assuming that they're all the same, for example, hydrogens, now this structure looks identical to what we started with. So by doing these two operations together, we've come up with a new structure, a new way of looking at it. That is what an improper rotation is. It's rotation followed by reflection to get back to where we are. And these could be a little bit harder to see now just because they're something different to us. So here's another example here. Allene also has what we would call an S4 rotational axis, because what we're going to start with is a C4 rotation. So that's where our 4 is coming from here. So that's a 90-degree rotation that we're doing here. And then we're going to have our symmetry plane here that we're going to reflect across so that we get back to the structure that looks identical to where we started from. This is an S4 symmetry improper rotation. So these will be important because we're going to see that, hey, sometimes we don't have a C4 axis. Sometimes we don't have the horizontal plane that we can use here, but we can still move from here to here by having this improper rotational axis. So it feels a little bit awkward at this point, but again, when we do some actual examples of this as we're putting them together, we'll see how this becomes more useful. Our last symmetry element that we have here that we've kind of briefly brought in is that of inversion. Inversion is the idea of we are going to take everything through the center point of our molecule and pull it through to the other side. So the easiest way I like to explain this is, let's say I gave XYZ coordinates to all of my atoms. So chlorine over here maybe has some X, some Y, some Z. If I want to do an inversion operation, that means that I take the X coordinate, make it negative X, make it negative Y, make it negative Z. So let's see what that looks like. I've labeled here, I've got chlorine 1 over here, chlorine 2 over here. If I do an inversion, now they have pulled through that center point into the opposing positions. Same thing, we could look at bromine. Look what happens where 1 and 2 go. They go through that center point across the molecule and get pulled back and forth. Same thing with this fluorine here. Same thing with the carbon here. They're all being pulled through that center of mass coordinate that we have here. And like I said here earlier, if we did a successive operation, so I could do another I inversion element symmetry here, we would just bring us right back to our initial stage here. So that's all inversion is. That one's a little bit easier to show mathematically than it is to show in terms of arrow drawing like I've done here, but hopefully I think you'll get the point from this. So that is all the symmetry elements that we're going to talk about. That's all we'll have and need for doing all of our symmetry work with molecules. So next video, we'll start seeing some more examples of this and see how we can start seeing these in our molecules. One of the things I'll keep saying is don't forget, use your molecule builders. So bring a molecule set with you to class. It can be super useful. All right, that'll do it for this video. Until I see you next time, be excellent to each other.